Good day. Here's another training session. I remain Makinde Topko by name. So I'll congratulate you for making it this far to the next training phase. So today we'll be starting with georeferencing. It's another phase of a practical training. I will be doing a lot more on practical today. So I'll use this opportunity to explain what is georeferencing and why it's important. Alright, so here's the question. What is georeferencing? You must have heard different definitions of georeference. So we've given you two definitions we can be able to explain better for you. So the first one says georeferencing is the name given to the process of transforming a scan map or area photograph so it appears in place in GIS. Alright. So now for this first definition, it's telling you that a scan map or area photograph, or be it a drone image, be it the image you took with your phone, maybe you're snapping an image, or let's say more like a map or a place, or you're trying to most of the time it's when you have a flat image that is taken with a photograph or with a scanner, so you are transforming that image to its right position on the earth surface, to its right position in a place that is known. All right, you can have an image taken on Google Earth, for example. Must have used Google Earth. All right, so the Google Earth image itself, maybe you just screenshot it with your laptop. When you screenshot it with your laptop, definitely it won't really give much information of coordinates attached with the image, but the image is carrying a location, it's carrying a place. All right, so but when you transform this image in ArcMap, it will be difficult for you to align the image with its right coordinates on the software. For example, now you're trying to put that same image you screenshot on Google Earth, you're trying to put it on your image or your data you're working with in ArcMap. You will see that it won't fall in the right place. So the idea of georeferencing helps you to put that image in its right place. All right, so the second definition says that georeferencing means that the internal coordinate system of that digital map or area photo can be related to a ground system of geographic coordinates. All right, so furthermore, it says a georeference digital map or image that has been tied to a known coordinate system, so users can determine where every point on the map or area photo is located on the earth surface. All right, so for this definition, it simplifies the first one. It says that the image itself, that's the digital image or area photo. So you see that you've been seeing digital image, area photo. This other one also says scan map. You'll notice that everything is talking about raster. All right, so it can be related to a ground system of geographic coordinates. All right, so it's trying to let us understand that this image or area photograph that has been taken from who knows where it was taken from can now be related to a ground geographic coordinates. All right, so this image itself can be aligned on the earth surface, can be positioned properly where it's supposed to be on the earth surface. So yeah, you can be able to what get location on every point on the map. That was telling you. So users can determine where every point on the map area photos is located. So if you can determine on the map that you just scanned, the map that you took with an area hardware or a digital image that was sent through your phone, you can be able to know which location every point is on the map. So georeferencing helps you to be able to reference, to be able to align any coordinate, to be able to locate anything on the map, be it coordinates. You can be able to do a lot more with that. All right, so it says that a georeference digital map or image that has been tied to a known coordinate system. So a known coordinate system generally means more of we generally have two types. We must have explained that before in the previous session. Coordinate system is just all about the way the earth is being projected. We have geographic coordinate system. Mostly the earth is seen as a geographic in a spherical way, like a ball. All right, and we have projected coordinate system. The earth is seen as a flat surface. So you choose a coordinate system with your map. You understand? So users can determine every point on the map where is located on the earth's surface. Alright, so in general, let me just explain it to us. You are taking an image that is unknown but the image itself carry location because you are it was taken maybe from an area, or maybe it was scanned on a map. If you see a map of Nigeria, you will see different states here. But if you put this map on the software, it won't place it on the right position because it is not carrying a spatial reference system, or let me say it's not carrying location information, it's not carrying location attributes, it's not carrying special information, it's not projected, it's not sitting on the earth coordinate system, so it won't position well on the software. So georeferencing helps you to put that same map that was taken for Nigeria on the earth surface. So if you overlay other layers like Lagos State, it will position Lagos State where it's supposed to be, overlaying with the Nigerian map properly. Alright, as we go further, if we go into the practical session, definitely you understand everything. So secondly, understanding how this works. Raster data is obtained from many sources. It can be a satellite image, it can be an aerial camera, it can be a scan map. Alright, so these images, wherever it may be from, have location. Some of them have location, like satellite data you download, some of them carry location. The location they will carry, you will see some of them saved as geotiff. Alright, some drone images that was captured, some of them carries location. Geotagged images, if you use your phone to snap some yeah, let's say a map or something with your location on, it's kind of carry location, but it won't properly georeference as well. So why some doesn't carry location, like when you scan a map that has been printed before, you scan it to produce a digital copy of that map, or an historical map that you took from a library. You see that those ones are hard copies, but you want to convert these hard copy maps to a georeference format. Alright, you see those ones doesn't have attribute details, they doesn't have location attribute details. Alright, so, and this might need slight adjustment to line up with your GIS data. That is the essence of georeferencing. So the next thing you do is you will need to use accurate location data. That means coordinates of those that relates to that map itself that was scanned. You need coordinates at minimum of 3 coordinates. Okay, minimum of 3 coordinates to be able to georeference your map properly. Right, you need minimum of 3 coordinates. So to be able to place, align, or georeference your raster data to a map coordinate system. So you use those coordinates, or maybe more like a reference place or a known reference place. For example, you took an image of let's say your street, an aerial photograph of your street, and that image is not georeference, because you are able to recognize maybe a shop or a building. Are able to recognize that place, and you align it with Google Earth. You can be able to align or scale that image to georeference. That's more like manual way, but the best way to scale or georeference your image is using a known coordinate, all right, of that place. So lastly, a map coordinate system is defined using a map projection, a method by which the curved surface of the earth is portrayed on the flat surface. So this is explaining what coordinate system means. So it's saying it's defined using a map projection, a method by which curved surface of the earth is portrayed on a flat surface. So this is for projected coordinate system. We have 2 types of coordinate system. We have one that is geographic and one that is projected. Mostly the projected coordinate system are best used for larger scale, where you're working with just an estate or a street or maybe a local government. You will need to convert that map to a projected coordinate system because you want to make measurements. Right, I don't want to divert into projected coordinate system and stuff like that. While the other one for geographic coordinate system is talking about the earth being spherical, whereby you have the earth as a ball. If you are working on a very smaller scale like the whole of Africa or whole of USA, definitely you'll not be considering accuracy in measurements. Right, so that's what it means. Alright, so here is an example. By my left here, you see a georeference map. By my right, you see an image that is not georeferenced. Okay, you can see similarities. Let me explain the first one, georeference map. This map is overlaying a satellite image, an online satellite base map. You can see the road that directs this one, it's aligning properly. You can see other road. If I should zoom in, let me open this, sorry about this. Alright, if I should zoom in properly, you see the image itself. The road here is in line with it. The road here also is in line. This one too is also in line. This is an image that was produced and later converted to digital copy, so we had to georeference it further. You can see the road there, everything aligned properly. And if you see my mouse over in this image, you can see the coordinate system below here reading properly. Alright, so this is an example of a georeference image. It's sitting properly on the base map because it's well positioned. Why by the second one here, you can see the earth's surface and the image itself is showing it larger than the whole earth. It's telling me that this small portion is even bigger than the whole world. So that's an example of an image that is not georeference. All right, so why georeferencing is very important is because it helps you to reproduce the map by extracting vector formats, other details on the map. For example, if you have a topographic map or an ancient map of a place, you can georeference it and extract the details in vector format like point, line, and polygon. You can have the road network, the footpath. You can do a lot of things with it. When you extract the vector format, you can do analysis with that. Now, another part again is that it helps you to make measurements and direction, north, east, south, or west. Okay, it helps you to know which one is north, which one is east, which one is south, which one is west. All right, so it helps you to make measurements. So if I should go to this layer here, you see that I can make measurements on this layer, going to distance, and if I should select kilometers, if I measure from this road here like this, all right, it's telling me that I have 0.1 kilometer. If I should measure further, I'm having about 0.2 further like that. That's about close to, that's a lot. All right, so it gives you much information to make measurements, and it makes it much reasonable with your data when you can make measurements. Another thing is it helps you to reference the map, ability to use the map as a reference. Okay, you can use the map as a reference for other projects. Okay, so if you are working on another project and you want to overlay another image that shows that speaks more about that information, you can use the same map as a reference. You can use it as a base map. You can use it to do other things depending on what map or what you're trying to do. So another one says you can carry out further analysis, structuring the vector property, make mention of that, and you can be used by another third party. So this georeference image, if I save it and I send it to another GIS expert, he can make use of this map instead of going further to make coordinates, pick coordinates of this place. You can georeference it. All right, once it's saved in GeoTIFF. And giving the image a location attribute is a very good thing. It makes sense with the map, and you can easily extract other coordinates of unknown places. This is another important part of it. You can know coordinates of anywhere here. If you see my cursor here, as I change direction, it shows coordinates of different places. All right, it shows coordinates by point here. It shows coordinate 3.343 and 6.617. If I should put it here, it changes the coordinate. It shows coordinates of different places. All right, that is another part that it is very useful. All right, so and I want you to list below what are other things you feel this georeferencing can benefit you. You can write it in the comment below while we proceed to analysis. Thank you so much for your time. You cancel this. We don't really need any project to be on. All right, once that is cancelled, I want you to follow me step by step so that we be on the same page. And if you are not on the same page with me, you can always backward and fast forward the video. Alright, so the first thing you have to do is make sure you set your environment properly. Alright, to set your environment, you double click or right click on these layers. Alright, go to properties. Once you've gone to properties, you'll see that it's saying no coordinate system. It's very important we specify a coordinate system. Let's go to projected coordinate system because we're working on a larger scale. We're working somewhere in Lagos State, Ikeja to be precise, in Nigeria. Alright, so you go to UTM and you go to Africa. Under Africa, you select MENA zone 31 knots. Alright, MENA zone 31 knots. This helps you to make your work much valuable when you want to make measurements or you want to take measurements. Alright, once you've selected this and it's also shown here, you click on OK. Alright, that is one. The next thing we have to do is to click on this add data button. If you can't locate your add data, make sure you right click here and select the layout button. Alright, so sorry, I believe not the layouts. Let me see the tools. Okay, not the tools. Standard. Alright, it's the standard. So make sure you have your layout turned on, your tools turned on, and standard also on. Okay, once you have standard on, you click on this add data button. Once you've clicked on add data button, navigate to the folder you've downloaded previously. If you can't find the folder, check the previous menu on the training page. You will see download data, something like that. Then once you clicked on download data, you will download the zip file. Once you download the zip file, I want you to copy the zip file or unzip the file to your C drive. Alright, so what I did, I'm going to navigate to my C drive here. I have my C drive. Inside my C drive, I have Georeferencing unzipped. Inside Georeferencing, I have other files we'll be working with. Alright, so I'm going to go back to my ArcMap. So once you've clicked on the add data button, make sure you click on connect to folder. If you click on connect to folder, make sure that you have unzipped the file and it is visible as a folder in your C drive before you do this. So once you click on this PC, alright, you scroll down to local disk. Once you scroll down to local disk, you will see the folder visible here in your C drive. It's called C drive because this is labeled as C, alright, and you click on Georeferencing. Once you've clicked on Georeferencing, before you click OK, make sure it is visible here. Alright, if this is not visible, make sure you repeat the step again. So you click on OK. So once you've clicked OK, alright, you will see previous data, Georeferencing, data, manual, results, test. You click on data. Inside data, you see Georeference. You click on Georeference. The map we'll be working with is Ikeja map Georeference. The rest of all these ones are for you to practice on your own. Alright, Ikeja map Georeference is what we'll be working with. So you click on add. You see this image doesn't have a special reference. That is why it is warning us. It says unknown special reference. So the next thing you are going to do, you click OK, because that is what we are going to be doing. We are going to be giving it a known special reference. Now this image is carrying an unknown special reference. Okay, even if it has coordinates labeled on the map, it's still unknown because the software cannot just automatically place it on its right position, even if that's coordinates labeled all over it. Right, so it's left for us to georeference it. So now, to georeference this image, the next thing we are going to be doing is to right click over here. If you find it difficult to right click over there, click on I think customize. You click on toolbars. Make sure georeferencing is selected. Once georeferencing is selected, you have it here. Alright, I believe we are on the same page now. So the next thing we are going to do is you make sure that this is selected as Ikeja map georeference. Ikeja map georeference. Make sure it is selected. This is the image we are working with, and make sure it's selected. If it is selecting another image, we'll be georeferencing this while it is referencing the other image, and that will cause problem with our map. So once this is selected and you are sure this is the image we are working with, the next thing we have to do, I want you to use this plus sign, or if you have your mouse, make sure you zoom to this corner, the first corner, and make sure you are able to view the number here and also the number here together or simultaneously. Alright, make sure you are able to view them simultaneously. You can see 3, 20, 20, 6, 37, 0. The reason why is because we'll be making use of these two numbers once the dialog box has popped up. So the next thing we have to do, you click on this add control points. Alright, once you click on add control points, you note that we are working with degree, minutes, seconds, degree, minutes, seconds. So I want you to put your cursor in this middle here. Make sure it's in the center of that cross. I want you to left click once. Make sure your cursor don't move. Once you've left click once, I want you to right click again. Alright, once you've done that, you will see input DMS. If you are working with decimal degrees, you use this first one. If you are working with degree, minutes, and seconds, you use the second one. Degree, minutes, and seconds usually comes with projected coordinate system. If yours didn't work or this is not highlighted, it's because we've not specified a coordinate system, which you have to do that from which we did from the beginning. Specify a coordinate system and select the right coordinate system, projected coordinate system, if it's a large scale. So the next thing, we will click on input DMS of long and lat. So now follow as instructed. The longitude is always E, the latitude is N. Okay, when you are working with a minus longitude, it is west, and a minus latitude, it is south. But because this is a plus, you will definitely not see a plus here. It is a plus longitude, a plus latitude. That is why we'll be working with eastern and northerns. Make sure this is selected as eastern and northerns. So the next thing we have to do is select 3. Alright, the next one will select 20, while the next one will select 20. And for latitude, we select 6. The next one will select 37, and the next one will select 0. Make sure it is exactly as it is on my screen. You have the eastern and you have the northerns, and you have 6, 37, 0 for this, and we have 3, 20, 20 for this. Once you've done that, you click OK. Your map will be directed to where it is located on the Earth surface. Okay, so you see, this is what we were explaining initially. Your map has been directed to its rightful position, okay, to where it's located based on the control points we've added. So to go to where it is located, I want you to right click on this map, on the layer, right click on your table of contents and zoom to layer. You see your map added with one control point. Okay, I want you to click on the zoom button. All right, draw a box round there to make sure it is selecting both this one and this one, both round there, so you can view this and this both at the same time. So you click on add control points the same way we did the last time. Make sure your plus sign is directly in the middle. You left click, alright, and you right click. Then you click on input DMS of long and latitude. For the eastern, remember this is for the eastern, this is for the northern. This is also called longitude, this is also called latitude, this is also called X, and this is also called Y. Alright, so you select 3, 21, and 30. You select 6, 37, and 0. Make sure this is selected as eastern and northern, and review your numbers, or else it is going to shift to its normal position. So this is 3, 21, 30, 6, 37, 0. Alright, for northerns and for easterns. Then you click OK. It's also going to scale itself or adjust itself to its rightful position. So you right click on this again, zoom to layer. Okay, you see the map is looking a bit bent. It depends on how you see it on your map. So we are going to do the third one. Like I said, it is minimum of having control points reference on your map is 3. Okay, you can have more than 3, but the minimum you should have is 3. So like we said earlier on, you zoom to that rightful position again. All right, we have 3, we have this. Make sure you zoom clearly so you can be able to see it very well. So you click on the add control point again. I want you to click on this and right click, input decimal degrees. So for this one, you repeat the same thing. Make sure it is correct. 321.30 and 636, 636 and 20. All right. So we have 321.30, 636, 20. Very good. So you click on OK. All right. So now we are going to the last one. You right click on this, zoom to layer. You click on your plus sign and go like this. All right, so once you've done that, click on this plus sign, repeat the same step again. If you've made a mistake, it should be, if you made a mistake like this, you see this is not directly in the middle, you right click on it and cancel point. Okay, if you made a mistake and right click on this, input DMX, and you put a wrong figure here, okay, let's assume we put a wrong figure here, okay, and you click OK. Alright, let's cancel this. Let's just assume it gives us a wrong figure. Input X and Y, you just give it OK. It's not really giving me what I want. Okay, let's just give this one 2 and give this one 4. You see the image is slant. To correct this, click on View Link Table. Okay, once you click on View Link Table, number 4 georeference, you click on it and you cancel it. If you want to repeat that georeferencing again, you click on that and you cancel this. You see it's back to normal. So you repeat the same process correctly. Click on this and right click, then you put DMS. Make sure you select the right one. This one is 3 for longitude, 3, 20, 20, and we have 6, 36 and 20. 6, 36 and 20, 3, 20, 20. Make sure this is still nothing, then you click OK. Very good. Now we have georeferenced the image. Alright, you right click on this and zoom to layer. Once you've georeferenced the image, the final stage is to save your georeference map. And it's always advisable you click on georeferencing, then click on rectify. You click on georeferencing, then click on rectify. Okay, once you click on georeferencing and click on rectify, select this folder. Once you select the folder, navigate to the folder you've connected to before, that's Geoinfotech. Once you navigate to Geoinfotech, go to data, go to Geoinfotech, and we have results. You now select, go back, just click on results. Make sure this is selected here. Anytime you see add on your right side, it's just for you to select the folder. It's not for you to open the folder. The folder you want to save your map, that is what you're going to select. So once you've clicked on result and it's highlighted here, you click on add. So now you're adding this so that the name that comes with this file will be saved here. So now I want you to rename this file called Ikeja Map Georeference 1. Ikeja Map Georeference 1.tif. Okay, once it is saved like this, just click save. It's going to take a while. Very good. Now your map has been saved, georeferenced. Okay, so be sure if your map has been saved, I want you to click on file and open a new document. Once you click OK, if you choose to save, you can save it just not to lose your data. Just click on save, yes, and you can give it any name of your choice. So now once you start a new map, click on this add button, alright, and navigate to result folder. Inside result folder, you see Ikeja map georeference, and you click on add. You see it didn't complain for any special references because this has already been added with a special reference. Alright, so if you have any question, please leave your comments below. If you have any issues with your map, make sure you contact any of the facilitator on the contact us page button. If you have any issues with downloading the data, make sure you reach us via mail or you contact us on the contact page. Alright, so I believe there's nothing much for us to do, so make sure you watch the next video to progress. If you are done with this video, click on the complete button below. Alright, so thank you so much for your time. Have a great day.